Bismillahirrahmanirrahim. Welcome to the International Research Class. For our discussion today, we will discuss about the one tools in the R softwares to the estimate the parameter distribution, namely the Optim. With these tools, we can cancel the difficulties of the mathematics when we are using the maximum likelihood methods to the estimate the parameter. Only one very important steps when we are using Optim. We must find the log likelihood of the density function. Only that the step you must understand when we are trying to using the Optim. Find the log likelihood and run the program. Okay, we will open our programming. For our discussion today, we will try to use this. We try to use the data like this one to try to estimate the parameter of the Weibull density function and the gamma density function, the parameters. Okay. For the first one, of course, like I say, we must find the log likelihood. Log likelihood, of course, we must know what is the density function. In the R programming, when we are talk about this density function of the Weibull, we only use a d Weibull. D Weibull, its mean is density function for the Weibull. And we are using this function, sums logarithm natural d Weibulls for the specific parameter shape and scale. It means we want to find the log likelihood of the Weibull density function. So after we have tried to find the log likelihood, now we using the Optim tools to the estimate the parameter. We give the initial value for the steps 1 and the scale 1. And then we give the name of the log likelihood. We use the LL for the log likelihood, and then you must put the LL here. Give name the MLEW. It means the Optim of the density function of the Weibull distribution. Okay, we can run our programming and we can check ours using the Optim to the estimate the parameter. Okay, we run here. Come to the console and we can check. Okay, our program to the estimate the parameter of the Weibull density function is a success when we are using the Optim tools. You can check here. If you want to know the value of the parameter for the scale and the shape, you just type MLEW. Okay, you can find here. This is for the set. This is for the set, and then this one for the scale. And then with the Optim, we can success give the value of the convergence is 0. It's mean our estimate the parameter using Optim is a success. Okay, after that, we will give name for this one is the SCW, and for this one SHW. Okay, if you type the SCW, it means scale. If you type the SHW, it means the shape. This is the parameter for the Weibull density function. So after that, we will try the Optim to the estimate the gamma density function parameters with the same way. The number one, the number one step, or the very important step, just only find the log likelihood. Like I said before, log likelihood, we must know the density of the gamma. In the R software, the density gamma using the D gamma. And if we use the operation logarithm natural and the summation, it means you want to find the log likelihood with the specified the parameter self and the scale. Okay. After that, we run our program. Okay, we run. So we use the Optim to the estimate the gamma parameter. Use the Optim, give the initial value for the step one and the scale one. And this one is the LL, the name of the log likelihood program. So you run here. Okay. And then to come to the console, you can check here. If you want to know the value of the parameter, you just type MLEG. Okay, you can find here. This is for the set and this one for the scale. And then your success using Optim because the value of the convergence is 0. Okay. After we are success, run the parameter. Of course, we want to make the comparison. Which one the best? Which one the better? Weibull or the gamma? So that why we are trying to use the density plot to make the comparison between the Weibull and the gamma. So for our discussion today, we give the value of the histogram. This histogram is for the real data, and then the density function Weibull for the specific parameter SCW and SHW. But for the data, we use XI. Don't use X again, but you must use XI. What is XI? XI, the series of number, start from the 0 until the 2 power maximum data with the step 0.1. This is for the XI. We need a lot of point to make the smooth plots. Okay. So use the XI for the density Weibull and the specific the parameter. SGW, it means the scale. Weibull density function, and SHW, it means the shape for the Weibull. So same way with the gamma density function, we must use Xi and the scale of the gamma as SG. And don't forget for this one. In our programming, sometimes we use red. Red is mean one divide the scale. We use as red in the R software when we are trying to make the plot density plot of the gamma. We must use the red. Red is mean one divide scale. So this one, I'm sorry, one divide set. Okay, this for the red. Okay. So after that, we are make the density plot. Okay. Oops. There is problem here. It's not all right. Okay, this one is SCV. Okay, this one is okay. This is HA. Okay, this one's shape and scale was. This is SC. Okay, this is S, and this one is a one divide S. Okay, wrong place. Okay, we run again. We try to run again. There's the gram. We run our program again. Okay, you can check here. You can see here. The orange one is a Weibull density function, and the pink is a gamma density function for the data that we have. We can see from this density plots for the gamma and the Weibull density function, it seems the same line. Okay, it seems the same lines. Seem the same lines. No significant difference for the Weibull and the gamma density function in the capture the histogram of the real data. So we can say here, we can use the two density function to make the probability modeling for the data. Okay. I think what we are talking for this today is a very nice topics. We are trying to give the easy alternative to the estimate the parameter by using the Optim, because with the Optim we can cancel the difficulties of mathematics when we are using the maximum likelihood, or when we are using the Norton-Raphson to solve the problem of the nonlinear function. We know that maximum likelihood will produce the nonlinear function. So if we want to solve the problem, of course, we must use the numerics methods. One of them, or the famous methods, we can call it Norton-Raphson methods. I think it's very difficult. It's very difficult if we are using the Norton-Raphson. But using Optim, the difficulties of the mathematics, we can cancel it. But the very important, you must understand what is the log likelihood, the density function. Okay, I think this enough for this time, for this our discussion today. Radu Yendra and Radu Institute. See you again.